Why is thermal expansion critical for F1 composite chassis? Imagine racing at over 200 miles per hour with the chassis constantly changing shape. That's what thermal expansion can do to an F1 car's frame. When the engine and brakes heat up during a race, the materials in the chassis expand. If this isn't managed well, it can cause serious issues. The composite materials used in F1 chassis, mainly carbon fiber reinforced polymers, are lightweight and very strong. But they respond to heat differently than metals do. As temperatures rise, these composites expand slightly, and that tiny change can add up. If not controlled, it can lead to internal stresses that might crack or delaminate the layers of the chassis. This could weaken the structure and make the car less safe or less responsive. One big challenge is the difference in how composite materials and metal parts expand. Metal inserts are embedded in the chassis to attach suspension, engine, and safety components. Metals tend to expand more or less than the composites, depending on their type. If these mismatched expansions aren't accounted for, it can cause the bond between the metal and composite to weaken or even crack. To prevent this, engineers use thicker laminated composite plates for these inserts. These plates help match the expansion rates and keep everything tightly bonded. This way, the chassis stays strong and reliable, even when temperatures change during a race. During manufacturing, thermal expansion also plays a role. When the composite layers are cured, they are shaped around molds or mandrels. The heat causes the materials to expand slightly, and if this isn't carefully controlled, it can lead to dimensional inaccuracies. These inaccuracies might weaken the chassis or reduce its fatigue resistance over time. That's why precise temperature control during curing is so important. It ensures the final shape and strength are just right. Thermal expansion also impacts how the chassis handles on the track. If the material expands or contracts too much, it can change the torsional stiffness, which affects handling and responsiveness. Engineers use computer models to simulate how the chassis will behave at different temperatures. They choose fiber orientations and resin systems that minimize expansion effects. This helps keep the car predictable and stable, no matter the heat generated by the engine or aerodynamic friction. In the end, managing thermal expansion is about keeping the chassis safe, accurate, and responsive. It allows teams to take full advantage of the lightweight strength of composites without risking damage or performance loss. Proper thermal management ensures the car remains reliable race after race, even under the intense heat of competition. That's why understanding and controlling thermal expansion is so vital in building an F1 chassis.